All right, welcome to our third unit of our AP Unit 5. This video is on enthalpy. The first law of thermodynamics states that energy can neither be created nor destroyed, which means that any energy that is lost by the system must be completely gained by the surroundings, and vice versa. It means that our amount of total energy is technically always constant. To be honest, that is false when you actually get into nuclear chemistry. We actually find that energy and matter can be actually interconverted, but we don't care about that yet. But in case you want to look that up, go ahead and look it up. It's kind of cool. So, a state function is a function whose value depends on the present state of the system only, not on the path that the system took to reach that state. Let me give you an example. Okay, we have a mountain. And this is the path that I took up the mountain. Okay? The distance traveled is not a state function, because it depends on the path I took. The altitude that I reached is a state function, because I don't care how I went, even though I did this weird little loop thing, my final goal just depends on how high I got up. Doesn't matter the path I took, it just depends on how high of an altitude I have. That is a state function. Enthalpy, denoted by the symbol H, is defined as the sum of the internal energies in a system and the work done on the system. Enthalpy is a state function, which means regardless of how work or energy is done or transferred, all that matters is how much energy is in the system when it's finished. Enthalpy is basically like the total energy that a system has. Let's pretend that system is you. So this represents all the food that you've eaten in a day, plus the thermal energy you gained by running around, plus the energy from the coffee that you drink, minus the energy that you use to digest some of your food, minus the energy you use to walk and breathe, and minus the energy that you use to run around. That total energy of how your intake and your output is basically represented by your enthalpy. So, and again, it's a state function. It doesn't really matter how that work is done. It just matters whether work was done or not. That's your total enthalpy. Unfortunately, it's generally impossible to calculate the exact value of energy in a system at any given time, mainly because it's constantly changing. But we can, however, try to track those changes in energy in a system. Commonly, we do this by examining what we call our change in enthalpy, denoted by delta H. Delta representing change, H representing enthalpy. Our change in enthalpy, again, delta H, equals the heat that the system has lost or gained while it is at constant pressure. You don't really care much if it's not at constant pressure right now. Most of your problems are going to randomly say while at constant pressure, just because that's how enthalpy is designed. Later on, we'll get to where pressure has changed a bit, but not quite your biggest issue. We can generally calculate our heat that has been transferred, which commonly we denote by Q for no obvious reason, and so we can calculate our delta H. Basically, instead of figuring out how much energy we have currently, we can figure out how much energy we've lost or we've gained or lost by calculating Q. And Q, again, represents heat. I have no idea why heat is represented by Q, but just try to remember that. Now, if delta H is positive, that means we have gained energy. So energy has been transferred into a system, which increases our total energy, which, hopefully you remember, means it is endothermic. So delta H is positive, endothermic. If delta H is negative, energy has been lost, meaning it has been transferred out of a system. We have decreased our total energy, which means decreased our enthalpy, and that process is exothermic. Negative, exothermic. All right, and that is our first part of, or that's kind of enthalpy. We'll talk a lot more about using enthalpy, but that's our definition. Again, it represents our total energy, We can't quite track the value, but we can commonly and will commonly track the changes of enthalpy. Thanks for watching.